going to be looking at non-right angle triangles. And we want to do a couple of things. We want to be able to find the area of a non-right angle triangle. Some of you should be going, well, hang on, I can already find the area of a non-right angle triangle. Can't we? We've got a formula. What's the formula for area of a triangle? Any triangle. Yeah, base times height. So area of a triangle is a half base times height, or base times height divided by 2. And that's all groovy as long as we know the base and what height are we after. Doesn't it have to be the vertical height? Yeah? So what's going to happen is you will not be given the vertical height. And that's okay because we've got another formula that will that will allow us to find the area of a non-vertical height triangle. All right, so here we go. Very technical. When we had right angle trigonometry, it was all about labeling properly here. Labeling the sides. We had hypotenuse, we had opposite, we had adjacent. With non-right angle, we also have to make sure that we can label not only the sides, but also the angles. Yowza. So just be careful with your spelling now, all right? Make sure you spell it correctly, otherwise it'll be wrong. So this angle we are going to call capital A. The other angle we shall call capital B, and the other one we will call capital L. No, C. Keep up with your excellent spelling. The length that is opposite angle A, it is called little a. Yeah, baby. And the length that's opposite angle B is called? No, little b. And you've guessed it, opposite angle C is little c. I will promise you, you do not have to label your triangle A, B, C, whatever. It's mainly used so you can suss what the formula is. Okay? So here cometh the formula. Now, we are going to have 3 formulas that we're going to look at. We're going to have the area, we're going to have the sine rule, we're going to have the cosine rule. But for each formula, well, for this one, you're going to have 3 different examples. Okay? Because we're going to find the area. We're going to find when you've got the area but there's a missing length, and we're going to find when we've got the area but there's a missing angle. Okay? But you'll see, quite nice, quite nice. So it's up to you. You might just have one column for area of triangle. Then you'll have another column for the sine rule, another column for the cosine rule, or you might just want to put it all on one page. Your call. So area equals a half AB sine C. And I could write this formula another 2 ways. I could say, and I'm writing it over here, so please don't you write it as well, just the one. Because the gist of this is AB sine C. Here's A. Oh, missed it. Here's A. Here's B, and we're looking at the angle C. So we want the 2 lengths and the angle in the middle. If any of you watch Friends, this is quite funny. So I could write it again, and instead of AB, I could have BC, couldn't I? But it would then have to be sine of angle A. I could go area equals a half, I've done BC, I could go AC. And then it would be sine of B. But we don't care. We're not going to label them A, B, C. All we're worried about is that is 2 lengths surrounded the angle. Correct? Are we good? Are we good? Are we good? Are we good? So if I now ask you, let's find the area of this triangle. Sorry, do you need more time to write that bit down? Sorry. Yep. Okay, so we suss And it said we're going to have 3 different formulas that we're playing around with, but we look at this, as soon as it says area, I'm doing 2 things. One, I'm considering my area formula, a half AB sine C, and the other thing is I'm sussing and going, have I got 2 lengths and the angle in the middle? Clearly I do, don't I? So it's a straight substitution, good mathematician, formula, and now sub. So what's my A and my B? 11 and 15, right? Does it matter if I say 11 times 15 or 15 times 11? Niet. It does not. Times sine 28. The only way you can stuff this up is if you don't have your calculator in degrees. Do we all remember how to make sure our calculator is in degrees? Just run through it just in case. So into normal menu mode. I'm looking up here degrees, but shift menu, scroll down, I can see my angle there is in degrees, but in case it wasn't, I would press F1, press exit, and we're good to go. So 0.5 times 11 times 13 times sine, I forgot, what was it? Was it? Well done. Did you look or did you remember? Oh, well done. You're better than me. Oh, I said 15. Did I say 15? I think I said 13. Oh, bad, bad. I thought I was doing so well. And it's on video now. Look at that. Memory is fading. So 38.73, right? 38.73, and we're finding an area, so it's centimetres squared. Squared. We just had a question. We're going, hang on, you've got angle C here, but it's actually angle B. Remember, I'm not labelling. I'm not labelling the triangle. All I want is I want to make sure that I've got 2 lengths and the angle in the middle. That's it. So you can have any two. Yep, so let's have a look. If I now asked you, find the area of this triangle, 33, we'll go 21 and 38 degrees. Can we find the area of that triangle? No, you cannot. Are we listening, people? So I've got 2 lengths and I've got an angle. Why can't I find the area? Zoe? Pardon? I need 2 lengths and I need an angle. I've got 2 lengths, I've got an angle. Why can't I find the... Yep. It's got to be around the angle. So this is the angle that I need and I haven't got it at the moment, right? Not enough information. So you would say, sorry, no, can do. Yes? Yeah. A, B, C, 2 lengths, angle in the middle. Absolutely. All right.
Also, the angle couldn't be on C.
That's right. The second, my board's back. The second type of question that you can get is like so. You can see quite clearly I'm now missing a length, but I have been given the area. There is no vertical height, so I'm not thinking a half base times height. I'm thinking area is a half AB sine C. I do try, I'm trying my hardest to write area rather than A, because capital A also represents the angle, but it's up to you. I'm not going to dock you if you don't. So good mathematicians, we write the formula, then what do? Sub. So I'll just stop for a minute to give you a moment to write down the triangle, and then you can sub. Okay? Sub. So instead of area, we know our area. So right underneath, we put, it says equals, I put equals. It says a half, I put a half. Times, we know that's a times in between. Right, what's my A and my B? 13 and X. So 13 times X times sine. And this time I do have my angle, it's 57. So your job is you want to get X by itself. So I have to undo everything that's being done to it. What is being done to it? Times, times, and times. So how do I undo a times? Divide. Say that a bit clearer of the mic. Divide. You are correct. So we will divide the other side by all of that. So we're dividing by a half times the 13, because we're still dividing there, and dividing by the 57, sine thereof. And that will give me x. So it's all up to the collator. Now someone just asked a question. What was that question?
What if we don't know that angle?
Well, lucky for us, there is the third example that we're about to do. So get that, pop in your calculator and copy down this next triangle. Okay, so 136, what was it, 0.3? All over 0.5 times 13 times sine 57. Right, you've just typed in what you see. Equals, and we get 25. I love that I'm showing you and you're not even watching. Okay, as soon as you see this, the area, because remember, I'll say it again, you're going to be having 3 different formulas that you could, in fact 4, that you could choose from. How do we know it's the area formula? Because it's given you meters, centimeters squared. So we write it down. I could do something like this. Let's add in fact, I should have had that there to begin with. So let's sub in. Do I have my area? So right underneath, I'll put the 231.4. It says equals, I put equals, right, a half. 2 lengths. Do I have 2 lengths? But which 2 lengths am I popping in there? Zoe. 30 and 24. Why? Right, because that's the angle that we want to find. If this was the angle that I wanted to find, then what 2 lengths would you put in? 33 and 24. It's that simple. But I will still, believe it or not, I will still have students who will just go, oh, I see 2 lengths. I'll just choose those 2 numbers. Doesn't matter if they're not surrounding the angle. Oh, 2 numbers, put it in. So concentrate and we'll be right. Okay, I don't know my angle, so good old theta comes to town. Now you're hitting the algebra. You want theta, but in order to get theta, we first are going to get sine theta by itself. So who can tell me what I will write now for this line? I will be your scribe. Pardon? 231.4 all over the rest of it. And I'm not even bothering. I mean, I know I can say a half times 24 is 12. I could have written that. But we might have yucky answers later on or decimals. And I'm just going to make the calculator do the whole thing. I'll just pause while you write that down. Okay, and therefore, to get theta by itself, what do we have to do to get theta by itself?
Oh, sine -1.
Correct, which we also call the inverse. All right, so we're going to go sine to the -1. I'm going to be a little bit wicked and just say that. I asked the other class, did they use their answer key at all on their calculators? And some of them went, what is that? I'm a big fan of the answer key, and I want to tell you why. You can pick up, if you've done something wrong, if this answer in here, what you're going to try and take the inverse sine or inverse cos of, if it is not in between -1 and 1, right? If it's outside of that, you're going to get an error. Won't do it. So it's either going to be an impossible triangle or you have stuffed up somewhere. You might have chosen the wrong values. You might have accidentally, your thumb might have slipped and you've actually done, you've actually pressed 2 instead of 24. So you need to make sure that you check. So could I ask you not to just type in sine to the -1 and so on, actually work this out first. So 231, fraction button, 0.4. Yeah, did you remember it? Yeah. Was it 33? You looked at me funny, Carla. 30! I didn't remember it. I was so excited and proud of myself to be shut down. Right, so less than 1, not bigger than -1, so I know this is all good. So now I go shift sign. I don't write it down. I do not write the decimal. I just go shift sign of that answer and above your negative value here, so shift your negative answer. and that means it's 40 degrees. Your scientific calculators are better, believe it or not, because they just have an answer key. You don't have to go shift answer. But anyway, so 40. And please, it's not 40 centimeters, it's not 40 meters, it is 40 degrees. Now, do you have to draw the diagram? I normally say no, but I do reflect when we were doing those skills tasks and had to flip back. You know, the Pythagoras question. It was really good with people who had their triangle drawn. It helped them a lot. So, your call. Area. Half AB sine C. I like that it's in alphabetical order. What's our two lengths? 12 times 13 times sine 45. Wackadoo, wackadoo in your calculator. Poof. So simple, it's not funny. Happy days, everyone's good, you can get an answer. Do we need to do B and C? What would this one be? B? BB? Half, 25 times 28 times sine 82. We're good, yeah? All right, next. Coming. Shh. We're not going to do 2. We're jumping the gun with 3. And we go, what is going on now? You think, oh God, it's the same thing, isn't it? 2 lengths, angle in the middle, away we go. Can we handle? Okay, we sort of just want a challenge. And here it comes. But not a huge challenge. So maybe just choose to do 1 from question 3. But I find them quite insulting. All right, 4A. Find the area. What is it you think the question is checking about your knowledge? That you know which sides to do. So which 2 sides will I use, Keats? Exactly, you will use the 7 and the 13, and then sine of 66, we're good to go. What about B? Houston, we have a problem. I've got the 2 lengths, but I do not have the angle in the middle. Is this one where we go, can't do it, can't do it? Big Dave?
You can do 180 degrees.
You absolutely can. So we've got 180 degrees are in a triangle. Do we agree? So therefore, this angle will be 180, take 53, take 31. I'm just giving you the heads up and then you can go and do your thing. That's why you've got to listen. And C, what's going on there? We've got 5, we've got 5. So these are my 2 lengths. But once again, I do not have my angle in the middle. Or do I? Pippa? Yes. But I don't have my angle. I can find it. That's what I'm asking you. And we're just saying that we've got our head down as we're explaining this. Stop writing and listen. Yep. No. Because I can't use the inverse sine because I don't have the area. I'm trying to find the area. So my issue is, how can I get this? Well, say that.
Can't you just use Pythag to get the other?
Absolutely. You could use Pythag. You could split it down the middle, get a right angle, and I would then use right angle trig, not so much Pythag. But there's another way to do it. Isosceles triangle. The 2 lengths are the same. What else are the same? The 2 bottom angles. So if that's 71, well, that's 71. Does that mean you can then find that's 180 degrees in a triangle again? Okay? So, what I would like you to do, you can't spend the whole time messing around on that skills task because we want to try and get a little bit of the area stuff done. And I, believe it or not, I'm going to even introduce you to another rule. Have to. We lose our Good Friday day. So, all right. So you might wish to carry on with this. You might wish to, when I'm free, call me over and go through a question. I think I'll give you the clue for the bearings question a little bit later on. Okay, so leave that one for now. So if you can get up to question 8 for this, that would be great. Now there's not a whole heap of stuff. Yay, good. Not a whole heap of stuff. Those who were doing the right thing, I thank you very much. Most of them got up to 8. So what I want to do now is, can you please open up your skills sheet, and I want you to read question 10 because it talks about bearings. So with bearings, and I tend to do this more with the non-right angle triangle stuff, we'll be doing some really good questions with that. And again, I'm going through this on the board and I haven't got eyes this way. So I don't want to see the tops of heads, I want to see eyes this way. And I don't need you to write anything down at the moment. So you're looking at the board, listening. Carla, you right? Yeah. All right, so we have got direction. If this is north, do we know what this one is? Never eat soggy wheat bix. One of my year 10s, he said, I remember that, miss, but I say news. And I went, that doesn't work for me. New. He goes, oh, I go this way. I was like, oh, okay, whatever works, as long as he didn't stuff it up. So the other thing, who's done orienteering ever? So would you know where to go? I can tell you where to go. True north is how many degrees true? 0 degrees true, which means east is 90 degrees true. 180. You've got it. And then we're back to 360. So if we read the first line of this question, what does it say? Where do the hikers go? 240 degrees. So whereabouts is 240, do you think? Yeah, somewhere around here. Do we have to get a protractor out and do it? No, no, no. How far are they going? Sorry, how much? 0.7 kilometres, okay. So 0.7 kilometres. And it's at this point where they stop. They might have a bite to eat. They might look at the kangaroos, the wallabies, koalas. How much can a koala bear? Who knows? And then, where are they going to go? Where? 300 degrees. So whereabouts would 300 be? If this is my new true north. Somewhere out here. So 270 is, oops, didn't mean to do that. Oh, I might keep that there. 270 is there. Yeah? So 300, a little bit more up. So we're going to go, and how far did they go for? Huh? Oof, so longer. 1.3. Now, even from my sketchy diagram here, although I am using nice straight lines, what do we think this angle looks like over here? It looks like a right angle. But can we prove it? Yes? Yes, we can. How? How? Well, the first thing we should have labelled is that this angle, all the way from here to here, what did we say that was? 240. And then this angle all the way around there was 300. So, doesn't that mean that this bit here, you could tell me what that bit is? 60. So again, we're just putting in as much information as we possibly can. Put. What is it that we need To get the whole angle, clearly we need that one there, don't we? We don't have it. Here's my clue, and don't call it out. I'll be nice. What can you tell me about the angles in between two parallel lines? What's their relationship? Yes, this angle and this one are all the same, they're alternate, but what about these two? They do add together to equal 180. That is called, anybody know? What's it called? Not sub, but supplementary. How is that going to help you find this angle? Where are your parallel lines? I'll give you a moment. Right, your original true north line here, and then your dotted line here, they're the parallel. Do you agree? But how does that help? So then you're going, how is that meant to help? Well, this angle plus which other angle have to add up to be 180? That one there? But hang on, we don't know that angle. Go, Michelle. Yeah, 360 all the way around the circle, 360 degrees. So what's 360 take 240? 120, which means this has got to be 60. Oh, well, that doesn't work, does it? Well, that's a bad question. When we talked about our triangle with A, B, C, once again, it's the same. So A, opposite the angle A is little a, opposite angle B is little b, opposite angle C is C, little c, right? Same. Alex, what are you doing? You're not meant to be typing at this point in time. You should have pen in hand and you're writing this down. When we used the area formula, we said that you needed to have two lengths and the angle in the middle, right? That was for area. With the sine rule, it is all about pairs. So what we need is a known pair. We need an angle and we need its opposite length. And there's going to be two ways we can do the sine rule. So the first one is when we are finding an unknown length, we're going to go with A over sine A equals B over sine B. And again, I could technically write equals C over sine C, but I don't need three lots of pairs. And remember, I'm not going to care if it's actually A or B or C. I just need an angle and its opposite length. That makes sense? Okay. And next lesson, what we're going to look at is if we find the angle, we're going to flip these fractions. We just like to have our unknown upstairs, right? So, tray, simple. Let's go EG. And we might as well take it from the book. So basic problem, this is an example from your current textbook. We look, we see, hey, have I got two lengths and the angle in the middle? No. Does it say area? No. But what I do have is I have this angle and I have its opposite length. Yeah, baby. I want to find this length and lucky for me, I have its opposite angle. So it's all about the pairs. Not oranges, not apples. Pairs. So we've got A over, I'll write it, A over sine A, B over sine B. I'm not labeling A, B, C, huzzah, whatever. I'm just going, let's start with my unknown upstairs. We like it right up here. So there's my length. It is opposite sine what angle? 113. Equals? 18. Yep, 18 over sine of its opposite, 41. And now we whack in our beautiful algebra. I don't want x divided by sine 113. I just want x. So how do I get rid of a divide by sine 113?
So
You just times. So we're going to go 18 over sine 41 times sine 113. You can type that straight into your calculator, no brackets required. Right? How do these questions get harder? Well, what if they gave you, and I should be able to do it now in my head, but we'll have to pause the video. So we're just saying, how could I mess with you and go, well, can I make this harder? Well, what if I gave you all three angles and I asked you to find x? So I'm just checking your understanding that you're going, it has to be x over sine 113, it's opposite. That's the only bizzo. You cannot go 18 over 20 sine 26 because that's not its opposite angle, yeah? So just stick with the fact that it has to be opposites, the pairs. This rule is a piece of pie. Would we agree? Thank you. So there's not a lot for 15C1, right? Look at that. That's it. Just that. Boom. So maybe do 2 from each. Yeah, if you want to, but make sure that you've got the sine rule finding the length under control. 15C.1. For homework and finish off, you shouldn't have much of your assignment to do. And obviously those people who did not use their lesson time to do the area stuff, you've got to do that. Alex, if you'd like to give me your laptop, that would be great.